Alright, now we got one that's factored for us already. We have x minus 5 squared on the bottom. If I look through my different rules, this is going to be an example now of rule number 2. Rule number 2 is where you have a linear factor raised to a power of n. So let's go ahead and write the setup for this one, and then we'll get our common denominators. So for this we have a1 over, what you do is you start with the first linear factor, and then you do the second one raised to the second power. So basically you start with that to the first power, you keep on going up until you reach the whatever power that one is. So that one right there, again, makes this a little bit clearer here, is going to be x minus 5 squared. So that's going to be your setup. So now that we have the setup, we need to get our common denominators. So we have this one. Okay, and then we need to get common denominators for each one of these. Now this common denominator is x minus 5 squared. I already have that from the first one and the second one. I just need to make this term have the common denominator. So I have a1 over x minus 5, and then I'm going to multiply this one by x minus 5 over x minus 5. And so this one I don't have to do anything with here because it already has my common denominator. So I'm going to leave this one alone. All I had to do was multiply the second term there. Alright, I get 7x over x minus 5 squared is going to equal, basically now I can put this together. I have a1 times x minus 5 over our common denominator, x minus 5 squared. And then I have this one over x minus 5 squared. Okay, so now I have that. The final thing I'm going to do is go ahead and write out my equation I'm going to be using for either one of my two methods. I have 7x equals a1 times x minus 5 plus a2. So that's going to be it. That's the exact equation that I'm going to be using. So now that I have the equation written, I can now do this by using either one of my two methods. Now, in the notes here, I went ahead and I did convenient values method, and I went through and I did that. Let me show you, this one actually might be a little bit easier to use by the equating coefficients. So I'm going to show you the equating coefficients method, and you have the other one, convenient values method, that's going to be in the notes. So let me go ahead and do this one by convenient values. Okay, now to do that, I have 7x. I'm going to go ahead and multiply this one out. So I have a1x minus 5a1, and I have plus a2. So that's what I get when I multiply everything all out. Now when I get the equating coefficients, means I'm going to match up the two coefficients. So when I do that, notice that the a1 right here, that's the only term that has the x in it. And so I only have one term with an x in it here. So automatically, because I have those, a1 is going to have to equal 7. Has to be, because that's the only one that has the x in it. So I'm done with that one. a1 is 7. Now I also have another equation here. I have these two numbers in the end, but notice there's no number written after the 7x. Well, this can be written as 7x plus 0. So actually each of these would have to be equal to 0. So I have 0 from this side here is going to have to equal negative 5a1 plus a2. Again, the reason why it's 0, there's no constant term. There's no term that comes after the x. So you can always have something written as plus 0. It's not going to change the original problem the way it was written. So now I have that. Well, I have two variables here, but I already found that a1 is equal to 7, so I can put that in here. So I have negative 5 times 7, then I have plus a2. And if I multiply that out, that's going to be negative 35. So when I solve for a2, that means that a2 is going to be equal to 35. So I found that one without putting in any convenient values. In this case, this kind of problem might be a little bit easier to actually use the equating coefficients method. So now how do we write our answer? Well, what we're going to do is we're going to remove the a1 that we have here, replace that with 7. And then I have 35 is going to go in there for a2. So basically your answer is going to be this one right here. The partial fraction decomposition is going to be this. And again, if you get common denominators, you'd be able to get back to the original one that you start with. But this itself, this right here, would it be your answer?